We're going to start by talking about the general formula for determining the arc length of a circle. So if I have a circle here, this angle here is called a central angle. Usually, we've talked about this very briefly in class. Instead of using like X or Y to represent the angle measure of an angle that we're trying to find, we often use this symbol called theta. It's a Greek letter that's usually used to represent an angle measure. So it's just like a little circle with a segment going through the middle, or like the diameter of the circle drawn. So theta is what we're going to use to represent this central angle measure. Now, because this angle is a measure less than 180 degrees, this arc here is considered a minor arc. So we're going to look at what the equation would be to determine this minor arc given a central angle, theta, and the radius of the circle. So an arc is part of the circumference of the circle. So it's not all the way around the circle, it's partially around the circle. So the formula that we use for this involves some ratios. So we're setting up equivalent ratios here. The first ratio has to do with angles. So theta is the part or the smaller piece of the circle that I'm interested in. So theta over all the way around a circle would be 360 degrees. So theta over 360. This is the first ratio, part over whole of the angle measures. The other side is going to be the arc length. For some reason, S is used as the variable or the letter to represent the arc length. So that's the part that we're interested in. And then all the way around the circle would be the circumference, which we know from last week is 2 pi r. So this is the general formula for determining the length of an arc of a circle.